learned our basic differentiation rules. And one of the rules we learned was that getting the derivative of something plus something or something minus something, well, that's quite simple. To get the derivative of something plus something or something minus something, you simply get the derivative of the first piece and then add or subtract the derivative of the second piece. I hope this separate f of x and g of x notation is not confusing you. I'm really thinking of this as one big function where f of x is the first piece of the function and g of x is the second piece of the function. Let's take a look at this function h of x and review how easy it is to get the derivative of something plus something, or in this case, something minus something. So I suppose I'm thinking of this 4x squared as the f of x and this 2x as the g of x. Anyway, to get the derivative of something minus something, we just get the derivative of the first piece, and the derivative of 4x squared is of course 8x, and then we subtract the derivative of the second piece, and the derivative of 2x is 2. But we're going to see today that getting the derivative of something times something or something divided by something, well, that's not quite so simple. You could write this product rule formula down in your notebook, but I would really rather you memorize the way we say it. To get the derivative of something times something, we're going to do the first piece times the derivative of the second piece plus the second piece times the derivative of the first piece. Here's our first piece and here's our second piece. Let me say that one more time. It's the first times the derivative of the second plus the second times the derivative of the first. So let me use that rule to get the derivative of h of x. I'll put the first piece, 4x squared, times the derivative of the second piece, and the derivative of 2x is 2, and then I'll add the second piece, or 2x, and I'll multiply that times the derivative of the first piece, and the derivative of 4x squared is 8x. Let's see if we can simplify that a bit. 4x squared times 2 is 8x squared, and then we'll add 2x times 8x, which is 16x squared. Looks like 8x squared plus 16x squared is 24x squared. The derivative of h of x is 24x squared. Now, let's go see that that is indeed true. I certainly didn't need to use the product rule to differentiate this function. I could have just rewritten it first. 4x squared times 2x is, of course, 8x cubed. And what's the derivative of 8x cubed? Well, of course, it's 24x squared. Likewise, getting the derivative of a quotient is not quite as simple as getting the derivative of a sum or difference. Again, you could write this quotient rule formula in your notebook, but I would really rather you just memorize the way we say it. F of x is on the top, g of x is on the bottom. The derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. I'll say that again. It's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Let's see if we can evaluate the derivative of h of x using the quotient rule. I'm going to put the bottom, 2x, times the derivative of the top, and the derivative of the top is 8x, minus the top, which is 4x squared, times the derivative of the bottom, and the derivative of the bottom is 2. And that's all over the bottom squared. Well, 2x, if you square 2x, you get 4x squared. We can, of course, simplify this. 2x times 8x is 16x squared, and 4x squared times 2 is 8x squared. And I'll put that all over the 4x squared. Well, 16x squared minus 8x squared would be 8x squared, and 8x squared divided by 4x squared would just equal 2. Now, once again, let's go see that that is indeed true. We certainly didn't need to use the quotient rule to get the derivative of hx. I could have just rewritten the function. 4x squared divided by 2x is 2x. And of course, the derivative of 2x is just 2. Let's take a look at example number 1. Now, I'm sure this first example would be much easier if we just FOILed this and then got the derivative. But we're here to learn the product rule. So let's differentiate f of x using the product rule. The derivative is going to be the first times the derivative of the second, and the derivative of 5 plus 4x is just 4. And then plus the second piece, which I'm going to put in parentheses, 5 plus 4x, times the derivative of the first piece. Now the derivative of this piece is going to be 3 minus 4x. That's a binomial. I really have to put it in parentheses. I put the first times the derivative of the second plus the second times the derivative of the first. Now we just need to simplify. I'm going to multiply this binomial times 4. I'm going to distribute the 4. So 4 times 3x is 12x, and 4 times negative 2x squared is negative 8x squared. I'll put my addition symbol, and then I need to FOIL 5 plus 4x and 3 minus 4x. So 5 times 3 is 15, and 5 times negative 4x is negative 20x. 4x times 3 is positive 12x, while negative 20x and positive 12x is negative 8x. And 4x times negative 4x is negative 16x squared. I have some like terms. My negative 16x squared can be combined with my negative 8x squared. That's negative 24x squared. And 12x and negative 8x is positive 4x. And finally, I have a positive 15. Looks like we got it correct. Like I said earlier, in number 1 we could have avoided the product rule by first FOILing this out and then differentiating. But in number 2, we absolutely need the product rule. Now notice, number 2 has a constant multiplier. There's a couple ways you could think of it. I'm going to think of it as 3x squared times sine x. It may even be useful to write it as 3x squared times sine x. So there's a clear distinction about what the first piece is and what the second piece is. To get the derivative of y with respect to x, I'm going to apply the product rule. Let me put the first piece, 3x squared, times the derivative of the second piece. The derivative of sine x is cosine x, plus the second piece, which is sine x, times the derivative of the first piece, and the derivative of 3x squared is 6x. There's not much I can do here. 3x squared times cosine x is 3x squared cosine x. And of course, when we multiply sine of x times 6x, we can't multiply this x with the 6x. So I'm going to write it 6x sine x. Now, the way I have it written right now is fine, but I suppose I can go one step further. I have one addition symbol, which means I have two pieces. Here's my first piece, here's my second piece. And I see that both pieces I can factor out of 3. I see I can also factor an x out of each piece. So this would be 3x times x cosine x. And then to get 6x sine x, it would be 3x times 2 sine x. Looks like we got this one correct as well.